Hello Year 10 and welcome to today's first lesson on chapter 20. We're going to be looking at sectors and particularly finding arc lengths of a sector. But before we do that, if you could please attempt the do now task in your exercise book. It's all to do with finding the circumference and the area of circles using the radius or the diameter given. You should be comfortable with these questions as the two formulas you need you are familiar with. So for the circumference you can either do pi times diameter, or you can do 2 times pi times radius, because of course the radius is half of the diameter, and then to find the area is pi times radius squared. I want the full answer please, then round it to 1 decimal place, so please use your calculator and pause the video as you do this. Right, very good, well done. We'll just quickly fly through the answers. So for circle 1 with a radius of 4 centimetres, you should have a circumference of 25.1 centimetres and an area of 50.3 centimetres squared. And the squared is important when we're looking at the area. For the second circle with a radius of 6, you should have the following answers. For question 3, you're given the diameter. If you've chosen to use this second formula, if that's the one you've remembered from earlier in the year, remember you could just half that to 2, or you can just substitute straight into this formula to get the circumference and you get 12.6. And then for the area, obviously you can't use the diameter, you have to half it to 2 to get the radius, and then you do pi times 2 squared, which is also an area of 12.6 centimetres squared. Don't worry, they're the same, that can happen. And then for the last one, we've got a diameter of 6, so you have your circumference, which is straightforward. And remember again, for the area, you must half the diameter to get the radius of 3, so pi times 3 squared is 28.3 centimetres squared. Right, this is our success criteria today. So to be able to calculate the length of an arc, we'll look at what these words mean shortly. So to calculate the perimeter of a sector, and again perimeter is a word you've heard before, and then to be able to answer problem solving questions and then have a go at some Hegarty tasks afterwards. Right, first things first, I would like you to copy down these two diagrams in your exercise book. You can sketch them, so don't worry, you don't need to get your compass out or anything like that. Just draw 2 circles and label the different sections with the correct labels that are given on each diagram. Pause the video as you do this. Right, good. As you can see from this first diagram, it's the arc we're looking for today, and we can see that the arc actually makes up the part of the circumference that goes with a particular sector of the circle. So if you think of a sector as a slice of pizza, it makes up part of the circle but not the whole thing. So we know how to find the whole circumference, which is all the way around. We're going to look at how we find the arc. You can obviously also have minor arcs and major arcs, and you should be able to tell that minor, meaning smaller or less important, is with the smaller sector, and then major, meaning larger or more important, is with the major sector. That's our major arc there. Right, if you could please, first things first, just record these two formulas. So this one here with the word circumference in, and then the equivalent one below. And just to draw your attention to the fact that you can use either the fraction multiplied by this formula for the circumference, or the fraction multiplied by this formula for the circumference. You don't do pi times diameter and 2 times pi times radius. You pick one and you go with it. Please pause the video whilst you record the formula down. Good, well done. We're going to have a look at an example together. I would like you to copy down the working as we go through, and also just quickly sketch down the circle, and there'll be time at the end of this slide for you to pause the video and do all of that. So we have our circle here, then we have our sector, and we're trying to find the arc length here. Now you'll notice that arc length is a proportion of the entire circumference, and that makes sense when you look at our formula, because we're trying to find the arc length here. Now that symbol there means theta, which just means our angle, so our angle is 30, and we're doing 30 divided by 360 because we're trying to find 30 as a proportion of 360 degrees, and therefore we can find the proportion that the arc is worth of the whole circumference, and that's when we do the proportion times by the circumference. First things first, we can substitute in the numbers that we know. Again, I want you to do this with your calculator, but just for this example, put the whole thing down. So we substitute theta with 30, and then we substitute the radius as 18. We can then simplify that if we want to. We can simplify 30 over 360 to 1/12, and we know that 2 times 18 gets us 36. So we can simplify our answer further. We should know that 1/12 multiplied by 36 is equivalent to 36 divided by 12, and that gives us 3. And if we were to ask asked to leave our answer in terms of pi, that's what we would do, because you know from previous work when we were looking at the volume of cylinders and the areas of circles, when you leave your answer in terms of pi, you don't actually have to do that pi part of the calculation. And quite often those questions could be on a non-calculated paper, but we want our answer properly, and to 1 decimal place we get 9.4 centimetres. If you could just put in the formula in your calculator with the correct values that we now know, just to check that you get that answer, and then copy down this worked example, please pause the video as you do this. Right, good. There's another example here. You can have a quick go at this on your own before we go through the example. I'm quite happy for you to write the formula with the substituted values and then your answer to 1 decimal place, or if you'd like to, you can similarly go through how we've done on this slide and put every stage of working out if you think that will help your understanding. So if you can pause the video whilst you find the arc length of this circle. Right, good. So if we've done it correctly, instead of the theta sign, we should have put 100, as that's our given degrees, 100 out of 360. Then we're using the 2 times pi times radius formula, so 2 times pi times 6. If you use the pi times diameter, you absolutely can, but you would have 100 over 360 times pi times 12. You would get the same answer, and you get 10.5 centimetres. Right, using that same formula, if you could please have a go at these questions in your exercise book and round your answers to 2 decimal places. If you're not confident how to do that, just write down the answer to a few decimal places, because that would absolutely get you method marks. Please pause the video as you do this. Right, good, we'll just quickly go through the answers. So to 2 decimal places, for the first one you should have 16.76 centimetres, then you should have 62.83 centimetres, 219.91 millimetres, so just be aware of that the units changed here. Then we've got a decimal number for our radius, it's 7.3, so just be careful that you check that. And we get 7.64 centimetres. Here, it is this big arc we're looking for. There's nothing drawn there, so we assume that's what we're looking for. And we should get 26.49 centimetres. Now here you should have been careful, because if you've made a mistake and your answer is not the one above, it's because you've put 80 over 360, but this is the given arc. So what we're actually looking for is that angle there. And we know that angles round a point of 360. 360 take away 80 leaves us with 280, so that's the degree you're doing over 360. Right, if you could have a quick look at this problem solving question, just pause the video as you do this and see if you can answer it. Right, good. So all we've got is a very similar question to the ones we've done on the previous slide, only now it's in a context, so a real life context. And if we read it together, it says the curved part of an anchor, that's here, is in the shape of an arc of a circle, and we can see that to be true. It has a radius of 1.2 metres, so that distance here is 1.2 metres, and the angle that isn't drawn for us but we're told about is 85 degrees. Now really, this question is exactly the same as that question. So when you get something like this, what you could do is draw it out in a way that's more easy for you to recognise, and then we know we just input this information into our calculator because we want the full answer, and then to 2 decimal places it's a 1.78 metres. Remember, don't worry, the answer is so small, it is in metres, so you sometimes end up with numbers that look less, but they are still worth a lot. Right, brilliant. What I would like you to do here is to calculate the arc length for each of these sectors, but then also calculate the perimeter. Now, if we're looking at the perimeter of these sectors, and they're called perimeters because you now have some straight edges, it's no longer called the circumference as if it is a whole circle. So we know how to find this arc length. It's theta over 360 multiplied by circumference. But once you get that answer, and if we look at A together, that's our arc length, 6.28. But we want the whole perimeter, so we need to add up this length and this length. Now we know that the radius, no matter which direction from the middle of the circle, and that's here, it comes from to the circumference, is always the same distance. So if that's 4, that's 4. So we have to add those 2 lots of 4 on, and then we get our perimeter, and in this case we would get 14.28 centimetres as our perimeter. If you could now pause the video and have a go at finding the arc length and the perimeters of all of the sectors below, that'd be brilliant. Please pause the video as you do this. Good. Now if we have a look, and I think I might have said earlier 6.28 as 2 decimal places, but actually if we read the question carefully, it wants our answers to 3 significant figures, so hopefully we've read that carefully and we've done it. So for B, again, 6.28 centimetres, don't worry that it's the same as this one. I know the angle is different. Oh, actually the angle's not given for that one, so don't worry if you can't do that one. We would get 6.28, but for this one here, we'd get 26.2. And then for this one here, we would get 10.5 centimetres, and here we'd get 20.8 centimetres. If we were then calculating the perimeter, we would know to add those missing values on. And the first one we did together, and again to 3 significant figures, it becomes 14.3. Again, apologies, the angle's not here for this one, but it's 18.3. For this one here, you're adding 2 lots of 10, so you get 46.2. For this one here, you're adding 2 lots of 2, which is 14.5. And for this one here, you're adding 2 lots of 7, which is 34.8 centimetres. Right, well done for getting through the PowerPoint. If you can now complete the relevant Hegarty tasks as set out on the guidance sheet, but just for information, they are 544 and 545 to support your knowledge and understanding. That'd be brilliant. And then next lesson, we'll start to look at finding the area of sectors and missing angles. Well done.